So from here we are going to start hardware based communication protocols. Okay. So what is the communication? First of all, communication is like sharing the data between the two devices, between the two persons, right? Just a second.
जतिन से बात कर लूँगा।
नहीं, करता हूँ
हाँ?
करता हूँ
कब करें?
आज.
वो आया हुआ है करना।
Yeah, communication, that means transmitting the data between the humans, between the human to device, device to humans, between the device to device, right? But there should be a proper format, right? There should be a proper arrangement of the data transmission and its protocols. Like as a human, we follow different kinds of architecture to communicate. We follow a common language to speak. We follow dedicated what we can say, like rhythm or some kind of frequency of our tone, right? So and proper translation of that words and languages. So like as a human we follow this different kinds of format to communicate to different kinds of persons around us, and also we use different kinds of communication techniques to communicate with other than humans, like animals, trees and everything, right? So in the same case, there are embedded hardware also use different kinds of formats, right, to transmit the data between the devices. So in an embedded system, a microcontroller rarely work alone. It must communicate with the sensors, display, memories, and microcontrollers and other extra things. So this happens with the common through hardware-based communication protocols, right? So what is hardware communication protocols? Is a method to allow two or more electronic devices to exchange the data reliably using dedicated hardware peripherals inside the microcontroller, right? Mostly, if you talk about embedded system, it used to communicate with the different kind of peripherals. It could be a sensor, it could be your actuators, it could be your storage system, or it could be any other controllers or other CPU, right? When we talk about the IoT, there are different kinds of wireless communication protocol right there. But right now we are discussing here only hardware-based communication protocol. So there are lots of communication protocol, but these are the common protocol that I think mostly used in every microcontrollers. The top communication protocols like UART, I2C, SPI, and CAN protocol. CAN is dedicatedly for the vehicle or emergency cases, right? But UART, I2C, and SPIs are common and very common components. Like, so instead of using manually logging the pins, hardware peripherals manage the timing, data shift, and synchronization automatically. So why we use communication protocol, right? To read the sensors and interface with the different kind of peripheral like display, to read the data from the memory card, to connect with the other different modules like communication modules like Wi-Fi, GSM, LoRa, Zigbee, right? And to communicate other controllers of the industrial controllers. Now all modern embedded IoT system depends on the communication protocols, right? These are the major communication protocols that we are discussing. First of all, the UART, universal asynchronous receiver and transmitter, right? Here we use two wires only, TX and RX. No clock line, simple and widely used, and asynchronous communication. Now, if we talk about the use cases of UART, mostly it used for the serial monitoring debugging purpose, right? We are using UART from the day ones, right? When we have started the programming, we are flashing our code into our controller, and how it is working that, right? In that case, right? First of all, we are not directly giving the code to our controller. There is one mediator between that is a USB driver, right? CP2102. So we are connected through the USB, right? Through the USB cable. First of all, we are giving the data to USB driver, right? And that USB driver is connected through the UART via to the ESP32. Okay. So that USB IC using this two wire, two connector, two pins TX and RX along with the ground and VCC to to flash the code into the our chip. So we are using UART in that case, right? There are some dedicated some GPS and GSM modules also, and also we use PC communication when we want to connect any kind of other modules to read the data or to control via USB. In that case, definitely you have to use the UART, right? And the advantage of UART is like it's very easy to implement. It requires very minimal wiring and good for the device to device communication. The second is I2C, inter integrated circuit. Sometimes it's like it looks very similar to the kind of CAN protocol, right? But it is little bit different from that. So it supports two wires, like in UART we has two wire TX and RX, but in I2C the same wire called we SDA and SCL, right? And SDA for to transmit the data and SCL to monitor the clocks, right? Then support multiple device on the same bus, right? I will give you the little bit more detail about each communication protocol in details in upcoming lectures, right? Right now we are just we are discussing its basic and uses about each communication protocol. And if we talk about the application for the I2C, there are different kinds of application for the I2C, that you should have OLED in your kit, right, which is working on I2C protocol. There are RTC models which work on I2C protocol. Different kinds of external EEPROM for the microcontroller which can be connected to the I2C communication protocol. And there are different kinds of environment sensors like temperature sensors and moisture sensor. Lots of sensors which support I2C communication protocol to communicate. What is the advantage of that? You only use the two wires, right? Multiple device supported and address based communication, right? Another communication protocol is SPI, Serial Peripheral Interface. It uses the four wires instead of two wire. It uses the four. First is MOSI, MISO, and serial clock, and CS, that means chip select. MOSI, that means master output, slave input, and MISO, that means master input, slave output, right? There is a concept of master and slave also, right? We'll discuss that, how one master can transmit to lot different kinds of multiple slave, right? And how a slave can be a master, how slave can transmit data to multiple other slaves in master. It is known for the high speed communication. That's why we use SPI in case of data storage or data reading, like to communicate with the SD card in full duplex communication. Applications like SD card, TFT display, right, ADC-DC converter, and external flash memory. Because these applications require very high speed communication, right, that's why we use SPI, which is known for the high speed communication. The advantage of this communication protocol is it's very high speed, reliable data transfer, suitable for the performance in critical system. Another common protocol is CAN controller area network, used in automotive and industrial system. Mostly it is used for like in every vehicle to communicate with it, because working of the vehicle is very critical, right? And the response from the sensors should be taken care on higher priority. So that's why CAN protocol is used in that kind of thing, like vehicles and other like robotic applications, and I think there are those applications who face the critical timing issues, right? In that, like we used mostly CAN protocol. High noise residential, right? There is a very rare chance that it would be affected by some external noise. Multi-node communication. It's like I2C. we can connect multiple slaves and master to each other. Then our next protocol is like RS485, long distance communication protocol. When we want to implement some kind of communication and inside any kind of plants, warehouses, right, through the wire, not wireless, and it is uh, dedicatedly for long distance communication, over the wide communication. Right? There could be some number of like its limit, but mostly as a long distance communication over the wire, we choose RS485. Differential signaling, industrial environment friendly. If we talk about this application, there is industrial automation is very common example for that. Modbus communication in PLC. Right? These are the comparison between the different kinds of communication protocol. How hardware communication protocol internally work? So every communication protocol has its format, right? And first of all, its initial bit, its shift register, control register, status flag, clock generator if required, interruption support. The CPU write the data into peripheral register, hardware shift bit automatically, and data is transmitted through the pins and a status flag and interrupt signal compilation. This looks very simple things, but when we go into the deep of that, right, it's fine. Okay, which are update करते हैं. Yeah, so yes, maybe it looks little bit simple, but when you will go into the deep of that communication, you will see lots of things like start bit, end bit, the check something, right? So it looks a little bit complex when we go into the deeper, but when we are in case of use cases, these are the very simple to use, right? So in real world embedded architecture example, ESP32 in UART, I2C, these are the use case like when we want to connect some other peripherals with our controller like ESP32 or STM32. So we can use the UART for the debugging purpose. We can use the I2C to connect the OLED display. We can use SPI to connect the SD card module, and we can also use like Wi-Fi module and TCP IP communication, RS485 for the industrial network, right? These are the common examples. Yep. So I hope it get clear. You can ask your doubts, right? And after completion that this thing, just mark it complete, go to the next, and here you have to give a simple test. Guys, are you there? Okay, just complete this test and let me know if you have any doubt, if you want to ask something. Then we'll move forward the next section, and do confirm if you completed this section. Following communication protocol. completed? Hello guys, is it done? Jitin, Rahul, Praveen?
Oh, not yet, I'm doing that.